right, here we go. We're about to start what is technically section 13.2 in your textbook. And it is the beginning of discussing trigonometry in a different way. To do this, we're going to do a quick warm-up. I'm going to ask you to hit pause on the video, pick a partner, read through this, and when you're done, answer the question. Go ahead and hit pause. Okay, so we are considering a blue arrow fixed to the x-axis. Notice that blue arrow here, that it's actually technically a ray that starts at the origin and extends along the positive x-axis. That blue here starts at the origin and extends along that positive x-axis. So when we begin to rotate it, this should have been the conversation you had with your partner or group of three, the question becomes, which angle is the largest angle, the one with the greatest measure? Is it the one that stops, that goes through 2, 2? Is it the one that stops and goes through 0, 1? Is it the one that stops and goes through negative 3, 3? Or is it the one that stops and goes to negative 1, 0? Now, when you consider all four of these, it becomes quickly obvious that the largest of these four is this 180-degree measure from this distance from the origin along the positive x-axis to the other side of the x-axis through negative 1, 0. But when we consider the order pair 5, 0, we have to think about it from a variety of perspectives, and this is where we're going to begin our conversation. If we talk about this original ray as rotating one full time around and stopping, then certainly the 5, 0 is the rotation, is the end point of the rotation that has the greatest measure. But what if the angle was 0 degrees? Then it's the least measure. What if the beginning blue that started here and went that way didn't rotate at all and stopped here? Then that's only a 0 degree measurement. So this has the potential to either be the smallest or the biggest. And with that, we're going to begin talking about where these angles start and stop with some key definitions. Now, in a minute, I'm going to put up a definition slide, and I'm going to give you a chance to actually fill out some words that go along with these three key terms. But I'm going to first use this picture to drive home the idea of what is considered first the standard position of an angle. An angle that is measured in standard position, first and foremost, is on an XY plane. Now, what's going to be really important is that from here on out, we are going to be taking what we consider right triangle trig, which has triangles often just thrown onto a paper. And now we're going to start to consider angles measured on an XY plane where my initial side of an angle is a ray that starts with one point on the origin that extends along the positive x-axis. That is the initial side. From here, we will talk about the rotation of an angle in a counterclockwise direction. And here, when it stops, wherever it stops, is another ray. So an angle is formed by two rays. We know that from geometry, that rotate around a vertex, but now we're placing that angle with the vertex at the origin, and we are having the initial side along the positive x-axis, and we rotate counterclockwise to consider a positive angle, and we extend wherever my angle stops, that terminal side of the angle. This is considered an angle in standard position. So go ahead and take a minute and hit pause on the video and jot down these three key terms. the standard position where the angle whose vertex is at the origin, and one ray is on the positive x-axis. That's my standard position definition. My initial side is this first side that extends here. The terminal side is considered rotating in a positive direction when it rotates counterclockwise and stops at the terminal side, which is the other ray of the standard position angle. Go ahead and hit pause, jot those down. This slide in particular emphasizes this idea of what's considered a positive rotation and a negative rotation. We will say that a measure that is in standard position, that has the initial side on the positive x-axis, that rotates in that counterclockwise direction and ends at a terminal side of the angle, which is a ray extending from the origin, we will say that that has, in this case, for example, a 120-degree rotation. If it went all the way around to here, it would be a 180-degree rotation. And if it goes the other way, if it goes clockwise from an angle in standard position, in which the initial side is starting at the vertex, or sorry, at the origin and extending along the positive x-axis, if it then rotates clockwise, no matter where it stops at the terminal side, it will be considered a negative rotation. So we're going to start to talk about the measure of angles. So the first one is pretty quick and easy. If I have an initial side that starts at the origin, extends along the positive x-axis, and rotates. In this case, it rotates to the beginning of the this portion, the positive portion of the y-axis. You would ideally tell me this is a positive rotation. And this then is a 90-degree rotation because it forms that right angle between the positive x-axis and the positive y-axis. In the second one, we're going to get a little trickier. Now, we got to consider what happens, and we're going to start to talk about this in a variety of ways. First of all, we want to decide, okay, what is this going to be positive or negative? This is going clockwise, so we're going to consider it negative. And though we will extend this much further in the days to come, in a most ideal world, you will notice that if I were to consider taking a point on this point at -2, -2, on the terminal side and creating this little mini right triangle, if this is -2 over and this is -2 down, even though those x and y values are negative, ideally what you hopefully notice is, oh, just like we talked about yesterday, if my two sides are the same, well then in reality, what I have is a 45, 45, 90 triangle. And if this is 45 degrees, then this would be 45 as well. So we would take 90, go back another 45, this would be considered a -135 degree rotation. Now if that kind of throws you off a little bit, don't panic. We're going to come back to that in the days ahead. Skip this. Oh, sorry, do not skip this. So look at this question, though, and you don't have to fully understand how we got -135, because, again, we're going to hit that pretty heavily over the days ahead. But you can certainly use that to use the exact same information to find what is the angle measurement of that rotation. Hit pause on your video, please, and try it. Okay, so this is the exact same point on the terminal side of the angle. The difference is that this rotation is positive. It goes 180 degrees around, but then we said, hey, if we drop this and create this little triangle, that is 45 degrees. So not only am I going 180 degrees to the semicircle, I then go an additional 45 degrees. This is a 225 degree rotation in the positive direction. So we're going to talk about how do you sketch an angle in standard position. And as we do, I'm going to weave in some keywords that we're not necessarily going to define yet. We're going to define them more in the days to come. But I'm going to start to weave them in so that when we actually define them formally, you're going to feel confident in them. To sketch an angle in standard position, there are a couple key things that we want to point out. First of all, we always want to have an XY plane. We want to have an initial side with a vertex at the origin and showing clearly that it extends along the positive x-axis. I'm going to then rotate my angle in the direction that it goes. So 36 degrees is a positive direction. It's going to rotate counterclockwise, and it's going to stop at a terminal side. Then I'm going to label that rotation. So one more time, these are your key concepts. You're putting the vertex at the origin, extending the initial side along the positive x-axis. You show that you know what the direction of the rotation is. I then stop the angle at in the appropriate quadrant to show the terminal side is, in this case, in the first quadrant, and then I label the size of the angle. Try B and C, hit pause, and give it a shot. Okay, so following those same exact directions, we draw an XY plane. And we then put a vertex at the origin. We extend the initial side along the positive x-axis. We're going 315 degrees. There's 90, 180, 270, 315. I'm going to stop, draw the arrow to show that it is going in a positive direction, draw the terminal side of the angle, and I'm going to label this as 315 degrees. I'm going to label that as 315 degrees. Now, the one thing that I want you to immediately start to get in the habit of is always knowing how far you are to the closest x-axis. So notice, in this case, you've got two ways to get to the x-axis. One is this portion right here, and the other is this portion here. This portion is clearly the smallest, the quickest way to get there. And so I want you to get in the habit of finding that size. Now, there are a variety of ways that you can come about that. I want you to hit pause and discuss this with your partner or group of 3 and see if you can come up with that value. Go. Okay, so if this full rotation is 360, but I only go 315, then I am left with 45 degrees. Starting tomorrow and going into next week, we will refer to 45 degrees as the reference angle. Now, the actual angle in standard position is what's there in blue, but the reference angle is what's there in green. Okay, so we're going to now go to negative 150. I've got my XY plane. I'm going to put my angle in standard position with the vertex at the origin, extend along the positive x-axis. I'm going to then show that I know how to rotate in the negative direction, which means that I go clockwise. I'm going to go past 90. I'm going to go not so far as 180. I'm going to stop in this quadrant, extend the terminal side. I'm going to sketch that arrow to show that I know that it's going clockwise in the negative direction. This is considered negative 150 degrees. Now, I just said a second ago, hey, I also want you to get in the habit of labeling the size of the angle closest to the x-axis. So hit pause, try it. Okay, this one is a little trickier. There are a couple different approaches you can take. One that's probably fastest is to say, hey, I was about to go 180, but I only went 150. How much is left? 30 degrees. Now notice, in both of these cases, even though they're in the third and fourth quadrants, I'm going to always list my reference angle as 30 degrees. Oh, sorry, I didn't mean that. I'm going to always list my reference angle as positive, no matter what. So notice, even though this is down here in this fourth quadrant, even though this is here in this third quadrant, I'm going to always list these as a positive reference angle. Now, if you look closely at this next slide, you'll see a vertex at the origin, extended along the positive x-axis to give me my, one second. I'm going to extend that along the positive x-axis for my initial side, and we are going to then rotate this to a terminal side that lands in the second quadrant. But what you also should notice is that there is a second way we can get there. We can also have my angle starting at the vertex, extending along the positive x-axis for my initial side, and we can get to this terminal side a different way. To do that, I could go in the negative direction. Notice that whether I am rotating in the positive direction 135 degrees or in the negative direction negative 225 degrees, my initial side here and my terminal side here are in the same place. When my initial and terminal side of an angle are in the same location, I have what's referred to as coterminal angles. Go ahead and jot that down. Two angles in standard position that have the same terminal side are considered coterminal angles. If you're ready, we're going to talk about what is the relationship between coterminal angles. So as you notice here, there's probably a gut feel. Just by looking at this and this, what do you notice? Just hit pause and tell your partner, or group of three. Sorry about the delay. I have someone checking in on our activities this afternoon with our interviewees. Ideally, what you notice is that the combination of these make a full circle. One way to think of it is, if I took 135 and I found the distance between 135 and 225, remember to find distance I would subtract, you would get 360 degrees. But here's a different question. If I knew an angle of 135 degrees was my original, how would I find a coterminal angle? Hit pause and discuss with your partner or group of three, how would you find the coterminal angle if it wasn't drawn there for you? Go. Ideally, what you notice is that if I knew I had a rotation of 135 degrees, if I just simply subtract 360, I get the negative direction. I get that negative 225 degrees. Now, the question then becomes, how many coterminal angles does a given angle have? If I have an initial side starting here and a terminal side ending here, how many ways can I get there? Does it have to be a negative one? Hit pause and decide how many ways are there. Okay, ideally what you've considered is not only can I rotate to get there, but I also could rotate one full time around and then stop there. Or I could go back 2 times around and then stop there. What does that mean for us? Well, if I have an angle in standard position, let's call it for a minute theta. If theta is an angle in standard position, how would I find coterminal angles? Well, how do we get around the circle? We add or subtract 360. We add or subtract 360. So this is where we're going to end today. Which of the following angles is not coterminal with any of the other 3? So take a minute, hit pause if you would, and try this. Okay. What we need to start to consider is the angle in standard position. here, here, and here. And you'll start to see where this reference angle really matters. For 300 degrees, I have this initial side. I rotate here, stop here. But this reference angle matters. This is a size of 60 degrees. Why does it matter? Because I know here that I have initial side, and I rotate back to get negative 60 degrees, but notice this green angle and this purple angle are coterminal because they have the same initial and terminal side. If I were to take negative 420 and I start initial side here and I rotate back 360 and go an additional 60, that reference angle, the size of that reference angle, even though it's a negative 420 degree rotation, because I'm going in this direction, the size of the reference angle is still 60. So notice now, this blue negative 420 starts, rotates all the way around, and then some. With this size reference angle matching that size reference angle, matching that size reference angle, my initial and terminal sides are the same. A, B, and D are coterminal. So what is the one that doesn't fit? C. Why? Because if I draw an initial side here and rotate in a positive direction of 60 degrees, my terminal side is in quadrant 1. C is not coterminal. Okay, you have a worksheet. It says angles and angle measure. You picked it up. And your job is to simply do, on the back, numbers 19 through 21. My fault, sorry. You're going to also do 24. You're going to do 25. And then I want you to look quickly before I assign this to you. You're asked in numbers 11 to 18. It says to find the measure of each angle. I'm going to ask you to do me a favor because it's actually hard to see the rotation. So to see the rotation, you're going to go on to Schoology to see the actual numbers on the worksheet, and then you're going to do the problems that are assigned, numbers 11 through 18 all. Okay? So you're going to do on the angles and angle measurement worksheet, you're going to do numbers 19 through 21, 24, and 25. When you're done, you're going to go on to Schoology to see the actual worksheet up close, and you're going to do numbers 11 to 18 all. Okay, with that, I hope you have a good rest of your day, and I will see you tomorrow.